So let's look at an example of graphing a rational function that has an oblique asymptote. So in this example, we want to graph the function f of x equals x squared plus 2x over x minus 3. We know it has an oblique or slant asymptote because the degree of the top is 2, the degree of the bottom is 1, and the rule is if the degree of the top is exactly 1 larger than the degree of the bottom, then we have a slant asymptote. So let's run through our steps for graphing rational functions and see what we get. So first of all, we know we are going to graph, we are going to find the y-intercept. We do that by evaluating the function at 0, and when we do that, we are going to get 0 over negative 3, or a 0. So that will be our y-intercept. Next, we find the x-intercept or intercepts, and we do that by determining when does the top or the numerator equals 0. Find the zeros of the numerator, and we can look at the factored form. We should have probably factored the thing first, so the top will factor into that and the bottom will factor into that. So the top has roots or equals 0 when x equals 0 or x equals negative 2, and those are our x-intercepts. And we can quickly classify those x-intercepts as being the type of x-intercept where where the graph goes through the x-axis, because they both have a multiplicity of 1, which is an odd multiplicity. Step 3, of course, is to then find the vertical asymptote, and those happen when the bottom equals 0, when the denominator equals 0, at the roots of the denominator. And so we can see that that's going to be at x equals 3. We can classify that asymptote and describe the behavior of the graph near that asymptote. We call this kind of asymptote an opposite type of asymptote because the multiplicity of the factor x minus 3, or the 0, the root, is 1. And when the multiplicity is odd, we know that the graph is going to go up one side of the asymptote and down the other side of the asymptote. Lastly, we find the horizontal asymptote. Now this one's easy in this case. We know there is no horizontal asymptote because the rule is if the degree of the top is larger than the degree of the bottom, then there is no horizontal asymptote. But as we said at the very beginning, we will have an oblique asymptote because the degree of the top is exactly 1 larger than the degree of the bottom. So we need to next find the oblique asymptote. Some books refer to this as a slant asymptote as well. So the process for finding the oblique asymptote is this. Look at your rational function, and it is actually, you can be thought of as a division problem, the top divided by the bottom. And so that's what we're going to do. We're going to take the numerator, fill in the 0 because we're missing a constant term, divided by the denominator, and do this long division. So let's proceed. X times x, or what times x gives us x squared? The answer is x. Put it above the x's and then multiply down. X times x is x squared minus 3x. Change the signs and add those two. The x squareds are gone. We're left with a 5x. Bring down the next term and start all over. What times x gives me a 5x? The answer is, of course, a plus 5. And then we take the 5 times x minus 3 to give a 5x minus 15. Change the signs and add. That's going to give us just a plain 15, and that's our remainder. Now, remember, we're trying to find the oblique asymptote. So the first thing, we don't care about the remainder, just ignore it. The oblique asymptote is right here. And so the line y equals x plus 5 is our oblique asymptote, and we'll need to graph that as an asymptote. And remember, both the horizontal and oblique asymptotes, their main purpose is to tell us where the far right and far left behavior occur in this graph, what those arms of the graph look like. Alright, so we're ready to graph this, and let's put all of this information onto a set of axes for us to graph. So let's see. So starting at the top, y-intercept at 0 and at minus 2. So our x-intercepts are at 0 and at minus 2. And we'll just quickly label these to remind ourselves these are both, the graph is going to go through both of those. We also have horizontal asymptote, or vertical asymptote, excuse me, at 3. So let's draw in the vertical asymptote at 3. And we'll label that one again to remind ourselves that the graph is going to go up one side and down the other. And then that leaves our horizontal our oblique asymptote, which is y equals x plus 5. And so that is a line. It's in slope-intercept form, so we can graph it using the y-intercept of 5, and then it has a slope of 1, so up 1 over 1. That gives us our 2 points to pencil in the oblique asymptote. We'll extend that a little bit. And so remember, whenever you draw in the either the horizontal asymptote or the oblique asymptote, at the ends you can go ahead and put in the ends of the graph. That's where the left and the right arms are. And so let's sketch our graph now. We know that it's going to be asymptotic down here. It's got to go through, and then it's going to have to go down this asymptote, because it can't go through this x-intercept and then go up the asymptote, because there is no x-intercept for it to cross. So it must go down. Well, if it goes down that side, then it must go up this side. And so the graph goes up that side, and then it's got to kind of whip around and become asymptotic right there. And so that is how we graph a rational function that has an oblique asymptote.